Here's Precalculus Concept 11C, dividing complex numbers, and there's 4 boxes. So let's dive into this one here. So the idea here is understanding what this word conjugate is, the complex conjugate. Okay, so let's say I have any old generic complex number like a plus bi. Okay, like as an example, let's say I have over here 2 plus I. The conjugate is the number a minus bi. Okay, it's a minus bi. So the conjugate to 2 plus I would be 2 minus I. If I had 3 plus 4i, the conjugate would be 3 minus 4i. If I had 0 plus I, the conjugate would be 0 minus I. And if I had 7 minus 3i, the conjugate would be 7 plus 3i. So basically, all you got to do is flip the sign in the middle between the two, okay? That's what a conjugate is. Now, what does a conjugate do? Here's the cool thing about this. If I take this number here, and remember everybody that this is a complex number, okay? It's a complex number because it has a real part and it has an imaginary part. And then I take this number here, which is also a complex number. So far so good, hopefully you're seeing this. If I take 2 complex numbers, namely 2 complex conjugates, and I multiply them together, I end up with a real number. It's the craziest thing in the world, so let me prove it to you. I'm going to use FOIL. So I'm going to go a times a. That's going to give me a squared. I'm going to do outer. So that's going to give me a negative abi. I'm going to do the inners. That's going to be a positive abi. And then I'm going to do the lasts. It's going to give me negative b squared I squared. Because b times b is your b squared and I times I is your I squared. Okay, look what you get. This is really, really cool. Notice that all this stuff in the middle cancels out because negative abi plus aabi is gone. So I have a squared minus b squared times negative 1 because I squared is worth negative 1. So the negative b squared times negative 1 just gives you a squared plus b squared. This is the coolest thing in the world because a squared plus b squared, you should notice that a squared is a real number and b squared is a real number. So the imaginary part goes away. So anytime we are taking a complex conjugate and multiplying it, anytime we're taking a complex number and multiplying it by its conjugate, we're going to end up with just the value of a squared plus b squared. We're going to use this in the next couple of boxes. Okay, it's a U-try, and no, it's not a joke. It really is a simple U-try. What is the conjugate to 3 minus 6i? Yep, it's just 3 plus 6i. Honestly, no trick questions there. Just making sure you're paying attention. Okay, box number 3, we're actually going to use the idea of the conjugate to divide complex numbers. We're not allowed to divide a complex number any other way than the method I'm going to show you right now. So here's the deal. I've got 7 plus 4i, and I want you to consider that an entire number. And then I have 2 minus 5i, and I want you to consider that an entire number. And we're dividing those 2 complex numbers. The strategy is as follows. We're going to multiply by a fancy 1. And the fancy 1 is going to be the conjugate of the denominator. So that's going to be 2 plus 5i. 2 plus 5i. Okay? And remember, we're not breaking any rules because this is just a fancy looking 1. So we're good to go. Okay, look what happens for yourself here. I'm going to move over here to the right in green. I'm going to multiply the top. So 7 times 2 is going to be 14. I'm just going to use FOIL here. Plus 35i. Plus the inners, which would be 8i, plus the last part, which would be 20i squared. I squared. Now, look at the denominator. This is your a, and the 5 is your b. Okay, this is your a, and this is your b. From box number 1, we know that the answer is just going to be a squared plus b squared, so we can just go ahead and write that in. That's just going to be 2 squared plus 5 squared. And that's all because of box number 1. When you take any complex number and multiply it by its conjugate, you get a squared plus the b squared. You don't even have to think about it anymore. Really, really cool. Okay, let's just clean up then. I'm going to have 14. I have 35i plus another 8i makes a positive 43i. And then remember, I squared is worth negative 1, so I have minus 20. And then in my denominator, I get the number 4 plus 5 squared is 25. Okay, and then continuing along, 14 take away 20 is negative 6 plus 43i. And then in my denominator, I have 4 plus 25 make 29. Now you'd think that we would be done, but we want to write this in standard form. And again, remember that standard form is a plus or minus bi. So what we want to do is we want to break up this fraction and say this is negative 6 over 29 plus 43 over 29i. Okay, the reason that we do this is because this part represents the a and this part represents the b. Sweet. Okay, box number 4 is a u-try. Go ahead and do the same method that we just did before and divide these two complex numbers. Okay, hopefully you got the right answer of 16 over 17 plus 21 over 17i. So you start by multiplying by the conjugate, which is a fancy one of 4 plus I over 4 plus I. You do your FOIL on the top, first, outer, inner, last. And then on the bottom, remember it's just a squared plus your b squared. Then, simplifying, I'm going to get, remember that I squared is worth negative 1, so this becomes a negative 4. And then simplifying down, breaking up my fraction, I get 16 over 17 plus 21 over 17i.